Hi everyone, myself Jyoti Prasad from RM Engineering College. In this video, we are going to discuss about the performance measurement of a computer or a processor. Basically, the performance measurement depends upon the various factors like the listed in this one. The most important measure of performance is how quickly the computer or the processor is going to execute the programs. Basically, the speed with which a computer executes programs is affected by these set of parameters like instruction set, what are the system of processor hardware and software, that includes operating systems also. So the technology in which hardware is implemented is also one of the major factor, as well as compiler which translates the user level programs into machine level programs. So these are all the some major parameters to measure the performance of a processor. So the first one is the technology. So due to the advancement in VLSI technology, very large scale integration, the fabrication of the processor on the single chip has been done. So here, due to the advancements in fabrication technology, the size of a transistor has been drastically reduced. Size of a transistors. So here we have two advantages, that the instructions can be executed faster and more transistors can be placed on single chip. Instructions can be executed with more fastness, and more number of transistors can be placed on a chip. So which is logical functionality can be improved and more storage capacity is increased. So this is done due to the advancement in technologies. The second parameter influences the performance measurement is parallelism. So performance can be increased by performing number of operations in parallel. So multitasking. So this can be implemented in many levels. Like for example, say instruction level parallelism. The simplest way to execute instructions is to complete all steps in current instruction before starting the steps of the next instruction parallelly. For example, the next instruction could be fetched from memory at the same time the arithmetic operation is being performed on the register. For example, A plus B it's performing. The next operands to be loaded is fetched and getting ready for the next operation. Once the first operation has been done, immediate then parallelly in the background it is doing the fetching operation, and the executing is parallelly carried on. So this type of parallelism improves the performance of a processor, as well as the time can be reduced, time taken to process. Multi-core processors. Nowadays, the term processor will come with dual core, quad core, octa core, the type of the processor. So depend upon the application. So whether it is a critical end application, we will go for high end 8 core, whereas we are using for normal use 4 core, like that. The performance metrics are listed below, like elapsed time, processor time. Basically, the elapsed time is nothing but how much total time required to execute entire program. That is nothing but elapsed time. So it depends upon the units of computer system. System to system, it will change. The processor time is nothing but the period during which processor is active for the execution of the program is called processor time. One of the other important parameter is cache memory. Nowadays, all the processor is coming with the memory, cache memory, which is on the chip itself. The internal speed of the performance performing basic steps of instruction processing is very high. Because why? Because each time it has to access the memory and coming back to the processor, it will takes time. That's why many of the new processors they will have a small amount of memory on the chip itself. So which makes the execution faster. One of the other important parameter is processor clock. When we are buying laptops or systems, we will check for the clock rate. What cycles per, what is the clock, or how much hedges. So processor circuits are controlled by timing signals. Like we will see the flip flops. So same thing, but like that, these process can be circuits can be controlled by timing signals. So at regular times, this clock defines a regular time intervals. How much time required for each task, like that is called clock cycle. To execute a particular machine instruction, the processor divides into particular basic steps. So each step can be completed in one cycle. so like a partitions. So that is called length p of a one cycle. And how we are relating that one to the rate is nothing but 1 by p is nothing but rate is inverse of the length p, clock cycle length. Nowadays today's processor, like I said, 100 millions of cycles per second can be performed. Okay, the standard measurement is cycles per second, which we call in electronic terms as hertz. Like I listed in the previous slide, first slide, one of the key parameter to decide the performance measure is instruction set. So if we see the simple instructions, we need more number of simple instructions to execute. If we see the complex instructions, they are complex in nature but requires only less number of steps to execute. So for example, a processor that has only simple instructions need large number of instructions to perform, then the value of S will vary. On the other hand, in individual instruction perform more complex operations are fewer in number. So this we are categorizing into two types. So simple instructions are called reduced instruction set computers, RISC. And the processors with complex instructions we can refer as complex instruction set computers. One of the other parameter, most important parameter, is spec rating. So it is nothing but the ratio of running time on the reference computer to that of running time on the computer under test. We are comparing the our processor to the reference processor. So hence how far it is, how with respect to how far it is performing well with respect to reference computer can be given as spec rating. Thank you.